across open water? Inside Japan's most unreal engineering marvel. The ocean has always been a barrier, vast, unpredictable, and unforgiving. For centuries, it separated communities, slowed progress, and challenged even the most ambitious human plans. But in modern Japan, where innovation meets determination, the sea became something else entirely, a challenge waiting to be conquered. This is the story of a bridge that shouldn't exist. Stretching across open water, far from the safety of solid ground, this engineering marvel stands as a symbol of what happens when vision refuses to be limited by nature. Before its construction, crossing this stretch of sea meant long ferry rides, delays caused by storms, and constant uncertainty. The idea of building a permanent connection seemed almost impossible. The waves were relentless, the winds were fierce, the seabed itself was unstable. Yet engineers and planners pushed forward. The project began not just with blueprints, but with bold questions. How do you anchor massive structures deep beneath shifting ocean floors? How do you build safely in waters constantly moving, where even small miscalculations can lead to disaster? And perhaps most importantly, how do you ensure the structure will survive earthquakes, typhoons, and decades of wear? The answer came through years of research, innovation, and precision engineering. Construction didn't start above the water, but far below it. Massive foundations were carefully placed into the seabed using advanced drilling and stabilization techniques. Each pillar had to withstand not only the weight of the bridge, but also the immense forces of nature pushing against it day after day. Workers battled waves, weather, and time itself, often operating in conditions where a single mistake could be catastrophic. Above the surface, the bridge began to take shape piece by piece. Gigantic steel sections were transported across the water and lifted into place with incredible accuracy. These segments, each weighing hundreds of tons, had to fit together perfectly. There was no room for error. Just a few millimeters off could compromise the entire structure. Every bolt, every joint, every cable was part of a carefully orchestrated system designed to distribute weight and absorb stress. But the true genius of this bridge lies not just in its size, but in its resilience. Japan is one of the most earthquake-prone regions in the world. Engineers designed the bridge to flex and move rather than resist. Special joints allow it to absorb seismic energy, reducing the risk of catastrophic failure. Wind-resistant designs help it stand firm against typhoons, while corrosion-resistant materials ensure it can survive years of exposure to salty ocean air. What emerged from this effort is more than just infrastructure. It's a lifeline. Travel times that once took hours are now reduced to minutes. Communities once separated by water are now connected by a continuous flow of people, goods, and opportunity. Economic growth surged, tourism expanded, daily life transformed in ways that were once unimaginable. And yet, standing on this bridge, looking out at the endless ocean on both sides, it still feels surreal. Cars glide across as if it's just another highway. But beneath them lies one of the most complex engineering achievements ever attempted, a structure built not just over water, but against it. This bridge is proof that even the most impossible challenges can be overcome with enough ingenuity, persistence, and courage. Because sometimes, the greatest journeys don't go around obstacles.